Okay, next up we're going to be talking about direct current or DC circuits. The first thing we're going to look at is EMF. So this is a capital epsilon. I make it an extra fancy E so that you don't get it confused with something else. You can make it however you would like. But EMF is the electromotive force. And it's basically the push on electrons by the delta V of the battery or whatever your power source is. The next thing is your R equivalent or R tote. This is basically the resistance of the whole circuit. So if you were to replace the entire circuit with a single resistor, that's the value of your R equivalent or your R total. And then finally, schematic diagrams. That's what we've been working with, where you guys have seen this a lot, where boom, boom, boom. You got the pictures that describe the sections of a circuit. It's just an easier, quicker way to draw it, something that looks more universal so that it's easy to tell. Let's learn what all of the shapes look like. So the first one is the wire, and that's basically the thing that carries the current, carries electrons. So it's just a line. A junction is the place where your wire is going to split. So where two wires meet, that's a junction. So this is where wires meet. Next up, we have the battery. Sometimes you'll see it with a plus and minus sign on it. Doesn't necessarily have to have that, but it's one side bigger, one side smaller. And this is what provides your EMF. There we go, fancy. Let's make the E a little better. There we go. Resistor. Technically, I believe it only has 3 lumps. I might have missed one on the bottom. But if you make it look fairly close to that, I'm going to understand the idea. And a resistor regulates current. Basically, it takes your electrical energy and it turns it into heat. As you put electrons through a resistor, it's going to heat up. As some of the energy gets used up, that's why the voltage drops across resistors and it limits the amount of current. The next thing we have is a switch. The switch looks like this. And a switch is basically just something you can use to open and close a circuit. So this can, make you an open or a closed circuit. Next thing is a light bulb. And what do you know it looks like? A light bulb. These are usually incandescent. So this is one that turns EMF into light and heat. It also will regulate current, but the only difference between a light and a resistor is that it's going to make visible light, whereas a resistor only makes infrared. Next, we have all of the ways we can measure sections about our current. So we have a voltmeter, and this measures voltage across, and I'm going to put this in all caps, across a section of circuit. So to measure voltage, you have to look at what the electric potential is before and after. So if I were to set up a circuit here and I wanted to measure voltage, I would have to go across it. So I would set it up in parallel with this resistor. So that's going to measure how much voltage there is from here to there, what that difference is. The next thing is an ammeter. And an ammeter measures current through a section of a circuit. So in this case, current is the number of electrons that flow through something. If you're in parallel, you do not necessarily have the same number of electrons flowing through you, but if you're in series, you automatically have to. So in this case, you have to put it with your resistor in series. So that's why it's measuring it through it. After that, we have an ohmmeter. Now, an ohmmeter supplies its own EMF, so that way it can find resistance. This one, we aren't really going to use this, but it's just for you guys to know. An ohmmeter measures resistance. Wouldn't you know it? The unit of resistance, you would call it a meter of that, and yeah, there you go. And finally, we have a ground. And a ground is basically just a place where place to distribute excess charge. We saw this when we did the different ways of charging in the electricity unit. A ground is just a spot where you can get rid of everything if you have extra or you need to reset it back to neutral. And that's all we have on DC circuits.